Okay. First, you're welcome to 2026. It's a beautiful year. Last year was beautiful. I believe this year will be much more beautiful. So welcome once again to 2026. So today I want to look at dynamic memory allocation. It is still part of learning C. I have now started with my team for 2026, which I told you we are going to look at data structure and algorithm. We are going to look at mathematics as a language. We are also going to look at C++ as a language. But somebody requested for this, so that's why I am doing it. And I skipped some part of it in the last class because I wanted to do it in this class. So today I want to look at dynamic memory allocation. So first, what did I teach you in the last or the previous classes? I taught you this. So I have this one. This is what? Memory layout. So we have memory layout, right? So here we have the code / text segment. Here we have the data segment, which is divided into uninitialize, uninitialize, and initialize data segment, right? Then here we have the heap. Here we have the stack memory, and then we have command line argument and environment, right? So our class for today, we are going to focus on the heap. Now, to manage this heap, we need 4 functions: malloc function, calloc function, realloc, and then we have the free function. So these are the 4 functions we are going to look at in the next few classes. Okay, the last class, I taught you something. I did this. So your program is logical and physical, which is what? This part is the hardware. So the CPU, the memory, and in this part, the compiler, the assembler, the linker, are on this part. Now, this part is the 0 and 1. This part is electrons. So the CPU and the memory don't understand all this one. So how then are they able to communicate? We have something at this point, one leg here, and that is what? The operating system. The operating system, like Windows. So that is the OS. So example of that is what? Your Windows. Microsoft, Windows operating system, or Linux, or Mac, right? So this is the one that understands this 0 and 1, and then understand these electronics, or electrons. So on this part, on this side of the logical, you have this. Now, it is really on this part that you have the stack, as the name stack, meaning you're having something like this. So if you are calling the main function will be stack, a frame will be created here. Then you call another function, it will come on top of the main function. Then when that second function finishes the activity, it will pop, which is what? Last in, first out. So that is on this side. But on this side, right, this stack is actually in, when you call the main function, is actually stored because this is the higher memory, this is lower memory. So the main function actually goes into the higher part of the memory. The next function you will call will go right under the next memory. So this stack is growing downward, while this heap is growing upward. They mustn't meet, otherwise the system will crash, right? So when you allocate memory in this heap, you must not forget to free it when you are done. That's why you need this guy. Otherwise, it will keep growing and growing and growing and growing until it will hit with the stack, and that becomes a problem. Okay, so I am going to dedicate classes to each of these, malloc, calloc, and realloc. But just to give you an intro into it, because the question was, what is the difference between, what is malloc and calloc, and what is the difference between malloc and calloc? So you have malloc, and then we have calloc, right? So this is what? Memory allocation, that is the meaning. Memory allocation. Why calloc is what? Contiguous allocation. Right? Now, malloc will allocate a single block of memory in the heap. Why this calloc will allocate multiple blocks of memory also in the heap. This malloc, right, is like assigning memory without a purpose. So if you try to access the memory, if you have not initialized it, you'll be seeing garbage values. So the government gives you a land, and the land is still bushy, right? So that is malloc. But in the case of calloc, when you assign the memory, when you allocate memory, you have to set it to what? To 0. And like I said, this is gives you a block of memory. This one also accepts one parameter, while this one accepts 2 parameters. So in each of the classes, I'm going to expatiate on this for you to understand more. So, but every time you allocate a memory in the heap, you can only access that memory through what? A pointer. So that is another function of what? A pointer. Now, how does it work? When you meet something like this, when you meet something like int, let's say int ptr. So this is integer pointer, and then malloc, right? Malloc, size of integer. So you are meeting something like this in your program. I'm still going to explain this in the malloc program. When you meet something like this in your program, what happens? This malloc is a function that will go to the what? Operating system, which is the kernel of the operating system. Now, I told you the operating system is kernel and shell in the case of Windows. So it will access the kernel and then tell the kernel, I need a memory that I will use later. But the purpose of that memory is not the kernel business. So I just need a memory of this size. So give me a memory of this size. So the operating system will go to the heap and check if there is space, right? It will create that memory and then give the address of that memory, the beginning of the address, to what? To malloc. And malloc will store it what? In a pointer. So what is the pointer? A variable that stores the address of another variable. So the address, the beginning address of that variable that will be allocated at runtime will be given by malloc to what? To this pointer. And then when you assign a value to that memory address and you are done with the program, you have to free it. So this is like the case of two people in a relationship and something happened along the way. One person decides to move on and then the other person refused to forgive, meaning you are still pointing to that address and nobody else can access you. It becomes a problem. So you have to learn to forgive and then set a boundary. So that is the concept of what? The free function. So malloc will assign a memory without a purpose. So if you try to access that memory, you will see garbage values. Calloc will assign a memory and set that memory to what? To 0. Realloc will be used to expand the memory that is given by malloc. So if tomorrow you got a piece of land from the government to build a school, and later you realize that 1 plot or 2 plot that was given to you is not enough, the government can decide to expand it, right? That is where realloc comes in. The purpose will remain. So maybe you were given a memory location to assign 5 values, and now you want to allocate, you want to bring in 3 more values. You now use realloc to increase the memory size, right? So that is what I want to show you. The 4 functions that I use to control this heap memory at runtime, when the program is executing, when the CPU starts carrying out the instructions, right? The memory can be created, allocated, and deallocated at runtime. So the next class, I'm going to teach you malloc proper with an example of C code, and then subsequently calloc and realloc. So we are done. So we'll move on to what? To our theme for this year. So till we see in the next class. Bye-bye.